Today we're going to take a look at the quadratic formula. And we already have two methods for solving quadratic equations. Our first method is to use the zero-factor theorem. And the zero-factor theorem states that if you move everything to one side and your quadratic equals 0, you can factor it and find the solutions by setting your factors equal to 0. The second way to solve a quadratic is to use the square root property. That square root property we looked at in sections 8.1. And both of these techniques for solving quadratics, they're limited. Because if you end up with a quadratic equation that can't be factored, you can't use the zero-factor theorem. And then if you have a quadratic that doesn't have a perfect square, then you would have to manipulate that quadratic to turn it into a perfect square to actually use the square root formula. So I would probably use, for a square root that can't be factored and that doesn't have a perfect square, I would use the quadratic formula. So let's talk about the quadratic formula. It states a quadratic written in the form ax squared plus bx plus c equals 0 has the solutions x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's actually take a look at the quadratic first. I want you to notice that in this quadratic, ax squared, bx, and c are all on one side of my equal sign, and my equation equals 0. Before you can even use the quadratic formula, your equation has to equal 0, so make sure it is in this form. Ax squared plus bx plus c equals 0. Alright, so quadratics come in all different shapes and sizes. The only thing that is consistent about all quadratics is that they always have the very first term. They cannot be missing the ax squared term. So if you take a look at our example here, we have our ax squared term, we have our bx term, and we have our c term, and it's all on one side and it equals 0. Well, quadratics also come in other forms too. So let's take a look at some of the other types of quadratics we might run into. We might run into a quadratic like this, where we have our ax squared term, and we have our c term, but we're missing our b term. If we're missing our b term, our quadratic, we can easily add it in as a 0x and still use our quadratic formula. And we might also run into quadratics that look like this, where we have our first term and we have our b term, and we're missing our c term. So if we run into a quadratic that looks like that, we can easily add our c term in by just setting c equal to 0 and adding 0 there, so that we can see all three terms when we're using our quadratic formula. So let's walk through an example of how to use the quadratic formula. Alright, so let's find our values of a, b, and c, because our formula states that we need to use a, b, and c. So a is the number in front of our x squared term. A is 3 in this case. Now b is the number in front of our x term, and we need to include its sign. So b in this case is a negative 5, and c is our constant term all at the end, and we need to include its sign as well, and c here equals negative 2. So to use a quadratic formula, it has to be memorized. I'm not going to give it to you on a test, so it should be memorized. To use the quadratic formula, all you're going to do is you are going to plug in a, b, and c directly into this formula and calculate the result. So for this case, let's go ahead and say x equals negative b, we know b is negative 5, plus or minus the square root of b squared, so it's negative 5 squared, minus 4 times a is 3, and c is negative 2. And you have to remember, when you substitute, to use parentheses, all over 2 times a, which is 3. So now let's go ahead and reduce what we know The negative of negative b is positive 5, plus or minus the square root of negative 5 squared is 25. And then we have negative 2 times 3, these two terms, negative 6. And then when we multiply that by a negative 4, we get a positive 24. And that is all over 2 times 3 is 6. So let's go ahead and reduce what's under the radical. We get 5 plus or minus the square root of 49 over 6. And then we know the square root of 49. That is 5 plus or minus 7 over 6. All right, so we have this plus or minus in the middle. That means we have two answers to our quadratic equation. Let's go ahead and separate them into their two distinct answers. We have 5 plus 7 over 6, and we have 5 minus 7 over 6. When we solve the first one, 5 plus 7 is 12 over 6. We get 2, and when we solve the second one, 5 minus 7 is negative 2 over 6. We get a negative 1/3. So we have two answers for this quadratic. We have x equals 2 and x equals negative 1/3. Okay, so now let's go ahead and talk about another type of quadratic that we might see. So I'm going to go ahead and erase this. I'm not actually going to solve the whole entire quadratic. I really just want you to see what you might encounter when you do your homework and how to solve it. So what happens if you are given a quadratic that has fractions in it? So let's take a look at a quadratic maybe that you might be given in your homework that looks something like this. Well, nobody likes to use fractions, especially in the quadratic formula. So let's use our property of equality that states we could multiply both sides of our equation by a number and still have an equivalent equation. So to get rid of our fractions, the LCD of those fractions is 8. So let's go ahead and distribute 8 across each of those terms on both sides of the equation. And we get 8 times 1/8 x squared minus 8 times 1/4 x minus 8 times 2 equals 8 times 0. 8 times 1/8 is just x squared. 1/4 of 8 is 2x minus 16 equals 0. And that was really nice. We eliminated our fractions, so we can go ahead and solve our quadratics. So in this case, a would equal 1, b would equal negative 2, and c would equal negative 16. And you could easily plug those straight into the quadratic formula and solve your equation. And that is it for this video. I will see you all in class shortly. Bye-bye.